Friends, welcome to my YouTube channel Maths Master. In this video, I am going to take one more problem set from Erwn Kreyszig's Advanced Engineering Mathematics, and this is the problem set 1.5. Okay, till problem set 1.4 I have already solved and uploaded, and in this case, we are mostly going to take these kind of questions. So we will not take questions on modeling. I have planned to make different videos for modeling questions from each of the sections. In this case, actually what we are actually going to do is from question number 3 to question number 13. And these are theoretical questions, so I am leaving this as of now. So let us start with the third question. Next question will be the third question. Before I start, I would like to request all of you who have not subscribed to my channel that you subscribe to the Maths Master and watch all the videos if it interests you for full video. Okay, and if you find that this could be useful to any of your friends or any of your college mate or anybody who is interested in this kind of mathematics, kindly share this video with them and click on the like button. Thanks a lot. Thanks a lot for joining. So this is the third question, which is actually first question for us and this appears to be actually a numerical question because all of them appears to be numerical and majority of the question are actually made or constructed around Bernoulli's theorem, which is also a part of a study of that particular chapter. And Bernoulli's theorem, can be represented as pxy is equal to qx. Okay? And we need to actually find if or integrating factor to be able to solve this kind of problem. First of all, we need to actually find out px after comparing this equation with this one. And px is not a variable, it is a constant of -1. And qx is also not a variable, it's rather is a constant 5.2. Therefore, if will actually be e to the power integration of px, which is actually -1. And this will be nothing but e to the power -6. Okay. So how it is used as per the rule? Then if will be multiplied with y here, and we will write e to the power -6, and then it will be multiplied on the right side also, 5.2 e to the power -6. Okay. And then integration will be applied on both the sides. I apply integration here on both the sides of this. Here you will get e to the power -x straightforward. It will remove the derivative sign and this will be integrated and it will become -5.2 e to the power -x plus a constant of integration c, which we have to take here. And then we divide the entire expression with e to the power -6. So we get here y, and here we get -5.2. And this will be actually c divided by e to the power -6 will actually make it e to the power x in multiplication. So this will become this. Therefore, our answer for this actually should be c e to the power x -5 only. -5.2. Okay. So let us move to the next question. So we have this question in front of us now to solve. Again, same comparison we will do with Bernoulli's equation and find out integrating factor. I can rewrite the equation as this one. This time we have qx as a multiple of x, but px is still we have constant number. Here we have px as -2 and qx we have -4x. So our integrating factor will be e to the power integration of px, which is minus 2 dx, and this is nothing but e to the power minus 2x. Now we apply here, and as per the process, what we will do, we will multiply integrating factor with y and then apply derivative signed dx, and this we multiply on the right hand side as well. So I will write 4x e to the power minus 2x. Now integration is to be done on both the sides. So when we apply a sign of integration on left hand side, this simply becomes y multiplication of e to the power 2x, whereas on the right hand side this will be little complicated because we need to actually apply integration by parts in this case. Okay, without that we will not be able to do. So integration by parts, we have formula of integration by parts of ub minus v du. Okay, we have to assume u as x and dv as e to the power minus 2x. Then this will become du is equal to vx, and this v will become minus of 1/2 e to the power minus 2x. Right. Therefore, x dx, x e to the power minus 2x dx is equal to ub, which is x and this one, x multiplied by, actually I have written it minus x dot 1.2 to the power e to the power minus 2x because we have minus here. I have taken it before x here. Otherwise this will be actually be x multiplied by minus of half e to the power minus x. I'll write it this way only. And then we have taken here minus e to the power 2x, and this will be du. Du is nothing but dx, straightforward. So we get here minus of x oblique 2 e to the power minus 2x. This minus and this minus will make it plus. So I write it plus and half, and this will be nothing but e to the power minus 2x dx, and this will be nothing but x oblique 2 e to the power minus 2x, and then this will become 1/4. 2 is already there, and minus 2 will come to multiply in the denominator once again while we integrate this. So this will become 1/4 e to the power minus 2x plus a constant of integration c. Now what we have got only this portion, which is integration as this one. So we need to replace it here. This needs to be replaced there. Y e to the power minus 2x multiplied by minus 4, and then minus x oblique 2 e to the power minus 2x minus 1/4 e to the power minus 2x plus c. And this will give us a result of minus 4. This will be 2x e to the power minus 2x, and this will be again plus e to the power minus 2x plus c. And if we take or divide the entire expression from left hand to right hand with e to the power minus 2x, we get 2x here plus 1 here plus c multiplied by e to the power 2x is equal to y. So this will be our solution. Our solution will be this one. Okay friends, let us move to the next question now. This question is again quite easy. IF will be simply e to the power integration of k dx, and it will be nothing but e to the power kx. So we have e to the power kx. This side is equal to e to the power minus kx multiplied by e to the power kx on the right hand side, and this will lead to apply integration on both the sides. This will become y e to the power kx. Right hand side will just become x plus c, and if we divide the entire expression with e to the power kx, on the left hand side we get just y, and on the right hand side we get e to the power kx c divided by e to the power kx, and this will become y is equal to x e to the power minus kx, x multiplied with e to the power minus kx plus c multiplied with e to the power minus kx, and this will be the solution. So friends, next question is question number 6 in the list, and this is actually an IVP or initial value problem. Compared to other ones, this one is quite tricky because it is going to take two rounds of integration by parts in this, because it is going to involve both exponential and trigonometric functions. Okay. This is quite easy. IF for us actually will be nothing but e to the power integration of 2 dx, and this will give us e to the power 2x. So our expression will actually become d delta oblique dx, and integrating factor multiplied with y on this side, and this will become 4 cos 2x multiplied by integrating factor e to the power 2x. Okay, and then the moment we apply sign of integration on both sides, this will actually, derivative sign will disappear from on the left hand side, so this will become y multiplied by e to the power 2x, and on the right side it will become 4 integration of cos 2x e to the power 2x dx plus c, where c is a constant of integration. For simplicity, I will leave c now and divide the entire expression with 4 so that it becomes simple. This I will write 1 oblique 4 e to the power 2x, and this 4 and 4 will go off, and we will be left with only cos 2x e to the power 2x dx. Now we know integration of parts is actually applied u dv is equal to ub minus v du, and we have to assume u and dv independently from this, and using Euler method I will assume u as cos 2x and dv as e to the power 2x dx. Right. Now here we get du is equal to, we would need to differentiate this, so this will be minus 2 of sine of 2x dx, and when we integrate this will become v is equal to half e to the power 2x. So our first iteration here will be 1 oblique 4 y e to the power 2x is equal to ub, which is actually cos 2x multiplied by half of e to the power 2x minus v du. V will be half of e to the power 2x, and du will be minus of 2 sine 2x dx. So here we have half of cos 2x e to the power 2x. This minus will make it plus, and this half will make it 1. Half multiplied by minus 2 will become minus 1, and minus 1 minus will become plus. We have here simply sine 2x e to the power 2x dx. Now we will apply integration by part again, assuming same thing, only change here will be Here it was cos 2x, now it will be sin 2x, and here it will be, instead of minus 2 sin 2x, it will be 2 cos 2x dx. So what we will get here, uv, we get u and v, so half of cos 2x e to the power 2x plus uv will become here sin 2x, half of e to the power 2x, okay, and minus of v du. So v is half of e to the power 2x and du is how much? Du is 2 cos 2x dx. We go, and this is nothing but e to the power 2x cos 2x plus half of e to the power 2x sin 2x, and this is nothing but cos 2x e to the power 2x dx. Now if we look at this particular expression, this is nothing but this one. Cos integration of cos 2x multiplied by e to the power 2x dx is nothing but 1/4y e to the power 2x. So we can substitute this directly here, this way, and it will become 1/4y e to the power 2x, half of e to the power 2x cos 2x plus half e to the power 2x sin 2x, and this directly we can write 1/4 y e to the power 2x. Okay. And we can simply bring it here, 1/4 plus 1/4 will become 1/2 y e to the power 2x and half e to the power 2x cos 2x plus sin 2x, and don't forget to put the sign of integration, a constant c, okay, which is actually a constant of integration, and therefore y will become, if we divide the entire expression with half e to the power x, this will become cos 2x plus sin 2x plus c divided by half e to the power 2x. This will become sin 2x plus cos 2x plus 2c, okay, e to the power minus 2x. Now what is the initial value? Initial value says at x is equal to pi over 4, the value of y is 3. So we keep it here, y 3 sin pi over sin 2 pi over 4 is actually sin pi over 2, and this will be cos pi over 2 plus 2c e to the power minus pi over 4 multiplied by 2 will be minus pi over 2. This is 1, this is 0, this is 2c e to the power minus 2. This will become 2 is equal to 2c minus pi over 2, or this will become simply c is equal to e to the power pi over 2. So friends, our final solution for this will be actually y sin 2x plus cos 2x plus 2 e to the power pi over 2 multiplied by e to the power minus 2x. Okay? Let us go to the next question. So question number 7th, we have arrived here, okay. I will fiddle with the given expression and make it a little bit changed in order to actually make it equivalent to a Bernoulli's equation. And for doing that, what I will do, I will first take out y prime, and that can be done only by dividing the entire expression with x. So if we divide entire expression with x, we get y prime on the left hand side, 2y oblique x here, and x square e to the power x here. Now I will write it minus x y and x square e to the power x right here. Okay. Now let us compare this with dy oblique dx plus pxy plus qx. And we have here px is equal to minus 2 of x, qx here we have x square e to the power minus x. In this case, we have both px and qx as a variable of x. Okay. Now integrating factor for this will actually be e integration to the power integration of minus 2x dx, and this will be nothing but minus 2x and e to the power minus 2 ln x e to the power ln x x to the power minus 2, and this will become x of minus 2 or 1 oblique x square. Okay. As per the rule, what we have to do is we have to actually write here that dx y and multiply it with the integrating factor, and on the right hand side we have to multiply this with the integrating factor. On the right hand side we simply get e to the power x. Now we have to apply sign of integration on both the sides. So here we will have y divided by x square and this will be integration of dx plus a constant of integration c, y oblique x square is equal to e to the power x plus c, and this will be y x square e to the power x plus c. So friends, we have come to the next question. This could appear to be very complicated, but it is not that complicated. It seems we have to compare with Bernoulli's equation again, and we find px is given as tan x and qx is given as this expression. I will not rewrite it again. Simply we need to find the integrating factor will be e to the power integration of tan x dx, and you know that tan x can be written as sin x oblique cos x dx. Okay, and if you assume cos x is equal to t, this will actually be giving us minus of sin x dx is equal to dt. Okay, or sin x dx is equal to minus dt. So we can replace e to the power here minus dt, and on the denominator it will be t. We get minus of ln t, or simply we get e to the ln t minus 1 or 1 oblique t. And 1 oblique t is how much? Since we have assumed cos x is equal to t, 1 oblique t will be 1 oblique cos x or sec x. Okay? I take it as 1 oblique cos x, and as per the rule I take it 1 oblique cos x, which is actually integrating factor, and then I take it y here, multiply right hand side with e to the power minus 1x cos x multiplied by 1 oblique cos x. Okay, this will go off, and when we apply integration sign on both the sides, here we will get y oblique cos of x, and this side we get integration of e to the power minus x dx plus a constant sin c, and this will be y divided by cos of x, and this will be integration for this will be 1 oblique minus of 0.01 e to the power minus of 0.01x plus c, and this will be nothing but minus of 100 e to the power minus of 0.1x plus c. Now we need to multiply the entire expression with cos x to eliminate y, and we get here minus of 100 cos x e to the power minus of 0.1x plus c cos x. Now, what is the initial problem which is given? Actually, the initial problem in this case is says that y will be 0 when x is equal to 0. Okay, so I write 0 here, x is 0, minus of cos, this becomes 1 and this becomes 0 will become e to the power 0 will, minus 0 will also become 1. So instead of writing it e, I will write simply 1, and plus c cos 0 will be 1. Okay. We have actually 0 is equal to minus of 100 plus c, or c will become 100. So we simply write c 100 here. So our answer will become y is equal to minus of 100 cos x e to the power minus x plus 100 of cos x, or 100 of cos x is to 1 minus e to the power 0.01x. And this is the answer for this particular question number 8. Okay. Okay, so let us go to the next question. So this is the 9th question is the next. This is IVP. Okay. IF will be e to the power sin x dx, and this will be e to the power minus cos x, and we can arrange y multiplied by e to the power cos x. Delta x is equal to e cos x multiplied by e to the power minus cos x, and this will become 1 because minus cos x will become 0, and e to the power 0 will become 1. Now after application of integration, this will become minus cos x and this will become dx plus a constant of sin c is equal to x plus c, and let us divide the entire expression with e to the power minus cos x will give us y here, and x divided by e to the power minus cos x plus c divided by e to the power minus cos x. This will be e to the power cos x plus c e to the power cos x. Right. Now what is IVP? IVP says that x is equal to 0, y is equal to minus of 2.5 or minus of 5. I take that I take y for minus of 5 over 2 is equal to x. 0 will, since it is 0 here, it will make it 0. So I don't write that. And c e to the power cos 0 will be 1, so this will be e to the power 1 will be actually e, and this will become c minus of 5 to e. So our answer for this will be actually y x e to the power cos x minus 5 to e to the power cos x, or e to the power cos x in bracket x minus 5 divided by 2e. Right, friends? So let us move to the next question. So friends, question number 10, it is here, and this is actually IVP question. Okay. It says that x is equal to pi omega 4, the value of y is equal to 4 omega 3, and we have to solve this. we have to actually rearrange the equation so that it can be compared with the knowledge equation. What I do is I write cos x is equal to 1 minus 3y sec x and y bar is equal to 1 oblique cos x, and this I bring it here and multiply. This will again be 1 oblique cos x. And dy oblique dx is equal to 1 oblique cos square x minus 1 oblique cos square x multiplied by 3y. This will become secant square x minus 3y secant square x, and we can take this particular portion on this side to actually make it 3 secant square x y is equal to secant square x. Now here you can see that px is actually this portion and qx is. Therefore, integrating factor in this case will be 3 of secant square x dx, and this is nothing but e to the power of 3 tan of x. Right. So, we can multiply y with tan of x here, e to the power of 3 tan of x. And again on this side, we can do this secant square x e to the power of 3 tan of x, right? And applying integration sign on both the sides, this will give us e to the power of 3 tan of x, and this will become integration of e to the power of 3 tan of x secant square x dx plus a constant c. Now here, in order to find this, we have to simply assume something in place of tan x, and what I do is I assume tan x is equal to t, and this will give y will do the first derivative of this will become secant square x dx, and this will become dt. And this becomes dt, and this is t. The resultant will become integration of e to the power of 3t dt. And this is nothing but 1 over 3 e to the power of 3t plus c, or y is equal to 1 over 3 e to the power of 3t divided by tan x, which is nothing but actually tan x itself plus c divided by e to the power. Now e to the power 3t is nothing but, since we have assumed tan x is equal to t, this actually becomes tan x, and this one and this one goes out. We are left with y is equal to 1 over 3 plus c e to the power minus 3 tan x. Now, what is the initial value? The initial value is that x is equal to 5 over 4, y is equal to 4 over 3. So we keep 4 over 3 here, 1 over 3 here plus c minus 3 tan of 5 over 4. So tan of 5 over 4 is 1. So we get it to the power minus 3. Therefore, this will become 4 over 3 minus 1 over 3 c e to the power minus 3. C is equal to, this will become 3 over 3 is 1, and this will, if we take this side, this minus will become positive, so this is e. Therefore, our solution will be y 1 over 3 plus e to the power q minus 3 tan x. In case you want to write it combined, you can write it e to the power 3 minus 1 minus. This is the answer. Okay. Let us move to the next question. 12th question we have to do. 12th question is actually okay. So this is the 12th question. We have to actually apply Bernoulli's rule because this is actually Bernoulli's equation. X dy oblique dx. We can write this equation as 8x cubed, and then we divide the entire expression with x. We will get dy oblique dx plus 4 oblique x here y, and this we will get x to the power q. This is actually equivalent to px, and this is actually what is qx. And if is actually e to the power 4 oblique x dx, or this will become 4 dx oblique x, or e to the power 4 ln x. This will lead to e to the ln x to the power 4 or x to the power 4. Our integrating factor for this equation will actually be x to the power 4. So we can write this as y is equal to 8 x to the power 4 multiplied by x to the power 4, and then we will apply integration. So on the left hand side we will get x to the power 4y, and this we will get 8x to the power 8 integration plus a constant of integration, and this we will get here is 8 oblique 9 x to the power 9 plus c. We can take this x and divide the entire expression with this, so we will get y is equal to 8 oblique 9 x to the power 5 plus c divided by x to the power 4, or 8 oblique 9 x to the power 5 plus c x to the power minus 4. Since this is actually initial value problem, we need to solve it. Initial value says that at x is equal to 1, y is equal to 2. So we substitute x is equal to 1 at these places, so we will get 2, 8 oblique 9, 1 to the power 5 plus c 1 to the power minus 4. This both will be 1, and this will be c 2 minus 8 oblique 9. This will be 10 oblique 9. Therefore, our final answer will be y is equal to 8 oblique 9 x to the power 5 plus 10 oblique 9 x to the power minus 4. Okay. So let us go to the next question now. So students, we have actually reached to the last question of this particular section. I would say the last numerical question. Okay. And the question is on your screen. Okay. This can also be actually beautifully variable separable question. There should be no difficulty in solving this. I will write 2.5 and hyperbolic 1.5x. Okay. And then take this one on the left hand side and dx on the right hand side. This will become is equal to 6 tan hyperbolic of 1.5x dx. Now we know sine hyperbolic of x derivative is equally cos hyperbolic of x. Okay, so this is nothing but sine x dx. But here we can write tan, this is sine of hyperbolic 1.5x divided by cos of hyperbolic 1.x dx. Okay. And cos hx hyperbolic this sine x. So we have to simply assume cos hyperbolic 1.5x is equal to t, and when we differentiate this with respect to x, we will get sine hyperbolic 1.5 x dx is equal to dt, and 1.5 multiple of x will actually come out here and it will become a constant multiple here. If we segregate, sine hyperbolic 1.5 x dx is equal to become dt oblique 1.5. Therefore, we can replace that with the 6, and this will become dt oblique 1.5 and cos is equal to t. Therefore, this becomes 4 dt oblique t. Now we have to apply sign of integration on both the sides in order to integrate. One will be here and one will be here, and this will give us ln y minus 2.5 is equal to 4 ln t plus a constant of integration ln c. This can be written as y 2.5 ln t to the power 4 plus ln c, and this becomes y minus 2.5 is equal to ln c t to the power 4. Okay. Now we have to, this ln will be here, and now we will be able to remove logarithm with anti-log, and this will be t4. C is nothing but a constant of integration, and t we had assumed cos hyperbolic 1.5x. We can go here and directly write y is equal to 2.5 plus c cos hyperbolic 1.5x to the power 4. And this is the answer, friends. Okay, so this is it from my side in this particular video, and I would like to request you that if you have not subscribed to my channel, you are requested to subscribe to Maths Pro and share this video with your friends. I'll be back with another video very soon.